Have you ever wondered how stars are born, shine so brightly, and then meet their dramatic ends? Today, we're diving into the fascinating life cycle of stars, a cosmic journey from birth to supernova, and sometimes, even to black holes. Stars are born in massive clouds of gas and dust called nebulae. These cosmic nurseries are where gas and dust swirl together under the force of gravity. Over millions of years, these swirling particles start clumping together, becoming denser and hotter. Eventually, the clump reaches a point where it starts to glow, entering the protostar stage. At this point, intense pressure builds up in the core, but the star isn't shining just yet. It still needs one key ingredient: nuclear fusion. When the core temperature hits about 10 million degrees Celsius, fusion ignites. Hydrogen atoms collide, merge to form helium, and release an immense amount of energy. This energy is what makes a star, allowing it to emit light and heat. Once fusion begins, the protostar has officially become a star, and it enters a stable phase called the main sequence. This is the prime of a star's life, where it spends most of its time. During this stage, a balance is created between gravity, which pulls inward, and fusion pressure, which pushes outward, keeping the star stable. Take our Sun, for example. It's been in the main sequence stage for about 4.6 billion years and has roughly 5 billion more to go. This stage can last from millions to billions of years, depending on the size of the star. And stars aren't all the same, they come in various colors and sizes. The hottest, blue stars burn through their fuel very quickly, sometimes in just a few million years. Red dwarf stars, on the other hand, can burn for tens of billions of years. But eventually, every star has to face the next chapter of its life. When a star runs out of hydrogen in its core, it begins burning helium instead. This shift causes the core to contract while the outer layers expand, transforming the star into a red giant. In this red giant phase, the star becomes cooler but much larger in size. Our Sun, for instance, will one day expand enough to possibly engulf Mercury, Venus, and maybe even Earth. In the core, fusion continues to create heavier elements like carbon and oxygen. But this phase is temporary, and soon, the star must confront its inevitable fate. For smaller stars like our Sun, the red giant phase is the beginning of the end. These stars shed their outer layers, creating beautiful glowing clouds known as planetary nebulae. What remains is a hot, dense core called a white dwarf. A white dwarf is the remnant of a once brilliant star. Over billions of years, it will cool and fade into a black dwarf, though none are old enough to exist just yet. But for massive stars, the end is far more explosive. When these giants run out of fuel, their core collapses under its own gravity, triggering an explosive supernova. This explosion is so bright it can outshine an entire galaxy for a brief time. After the supernova, the remains of the star depend on its mass. Some will become neutron stars, incredibly dense remnants where a teaspoon of matter would weigh billions of tons. And the most massive stars? They leave behind black holes, regions of space where gravity is so strong not even light can escape. Here's the amazing part: when stars die, they release the elements they've created, like carbon, oxygen, and iron, back into space. These elements go on to form new stars, planets, and even life itself. In fact, every atom in your body was once forged inside a star. We are, quite literally, made of stardust. And that's the breathtaking life cycle of stars, from birth to death and beyond. Stars are more than just distant lights in the sky, they are the universe's way of creating and sharing the building blocks of life. So next time you look up at the night sky, remember that we're all connected to those stars. If you enjoyed this journey through the cosmos, don't forget to like, subscribe, and let us know your thoughts in the comments.